G'day Year 8 mathematicians, and welcome to a new topic for maths. So if you can just draw a line under last work that you've done there and have today's date, and the title will be Investigate Positive Powers of 10. Now I've got a do now task on your screen for you there. If you can just write out those calculations for me. There are 12 there to do in total, and if you pause the video and work your way through those for me now, please. Okay, so the kind of idea is this, just to see if we can just remember how to multiply by various powers of 10, 10, 100 and 1000. So hopefully we've done well on these. I'll put the answers up for you now. Okay, fortunately I got full marks, so hopefully you've marked yours and got the same as well. So for the hook for today, what we're going to have a look at is Eva, this young lady here, has come up with a suggestion to say that 10 times 10 times 10 is the same as 10 to the power of 3, and 10 times 10 times 10 times 10 would be 10 to the power of 4. So Eva thinks she has spotted a pattern there. What connection can you see in Eva's examples? And could you use those examples she's created to help work out what's meant by 10 to the power of 7? Could you then work out 10 to the power of 7 times 10 again? And what would be the meaning of 10 to the power of 20? So I'm going to give you a chance to work your way through those. Have a think if you can see those patterns. If not, don't worry, we're going to try and solve this by the end of the lesson. You'll be able to go back and you should be able to answer this a lot more confidently. Okay, now that you've had a go at that, then we're going to move on and we're just going to see what we're going to be covering for the most of today's lesson. So we're going to explore the positive powers of 10, understand the benefit of writing large numbers as powers of 10, and be able to compare positive powers of 10. So, what better way to introduce a topic than with a terrible joke? So, where do mathematicians like to swim? In the seas. And another secondary little joke there, probably would make a fantastic t-shirt as well. So, indices, that's probably a word we have come across before. It's the one on BIDMAS, that second letter I, that some people do forget about. It's the less obvious one there. So indices is the mathematical term for power, and sometimes referred to them as index numbers. The word indices is simply plural for index. Okay, so this can be a number or letter next to a base number or letter. So for the example there, we've got 10 to the power of 4. The larger number there, the 10, the one that's written bigger, that's the base. The 4, the one that's written sort of top right, that is the index or power. Okay, so just make sure that you do not ever multiply the base with the power. So 10 to the power of 4 means 10 times 10 times 10 times 10. It does not ever mean, for any number or letter, 10 multiplied by 4. Don't ever fall into that trap. So just make sure you've got that basic notation written down so you know what we're referring to as the base and what we refer to as the index or power with those interchangeable terms. So let's just copy and complete this quick table for me. So you're going to work your way through these. I want to see it written as a normal number, then as a power of 10. So for example, on the second one, 10 times 10, in the normal number box we would write 100. As a power, we should recognise that as 10 squared. So just copy and complete the rest of that table nice and neatly with a ruler into your book for me, please. Okay, hopefully we've done a go at that, and that should be what you have produced, and you're hopefully as well starting to see that pattern with the power, looking across what that power number is compared to the number of tens that we're asking you to multiply by. So, cool question. 30 seconds to think, and then you're going to have a little bit of a share. So obviously we can't quite share as we would used to, but I'd still like you to have a real think in your own head here of what this would mean to you. So, Annie's multiplying by powers of 10. She says it's nice and easy. You simply add zeros. So based on the last one, 10 times 10, 10 squared, that's a power of 2. We are adding another 0 on. It sort of works for that. But she's suggesting then that 2.6 times 10 you're going to add a 0 on the end and end up with 2.60. Okay, now we should know straight away that she is wrong. What I want to know is, why is she wrong? And then you're going to correct her mistakes and then work out some further multiplications afterwards. Now, this is in your worksheet that comes alongside this lesson, so by all means get that out and have that with you now. There's going to be a few questions throughout the PowerPoint that will refer back to that, and then at the end of it you'll be invited to finish that worksheet completely for us. Okay, so if you pause the video, get that worksheet there on positive powers of 10 and work your way through those questions for me, please. Okay, so hopefully you've had a good go at that. And what Annie is doing incorrectly there is it's not just a case of adding zeros. We want to be talking more about place value. It's moving that decimal point. So 2.6 times 10, as we're multiplying by 10, that shows that we're going to shift the decimal place 1 point to the right. And then on 2.6 times 100, it's 2 places to the right, giving us 26 and then 260. So remaining answers are appearing in there. And again, if you can just mark that worksheet for me. Okay, so next up is here are various numbers. Some are written as numbers, some are written as standard form with their powers. What I would like you to do, and make sure you start with the smallest first, is to put them in order of size. And see, is there a good method to help sort these out and make your job a little bit easier for yourself? Okay, so once again, pause there and have a go at sorting those 7 numbers for you, please. So on this one, I'd perhaps suggest you either convert every single number, so it's in the index form, so 10 to the power of something, or you converted them all to ordinary numbers. Okay, whichever method you've chosen is absolutely fine, but far, far easier if you convert them all to the same. And this should be the order you got, starting with the smallest. There we go. So the largest one there is 10 to the power of 12. Okay, and this is now question 4 on your worksheet. Just to really solidify this knowledge of these patterns with the power of 10, I'd like you to complete those for me in the worksheet. Once again, now that you've done those, can we just mark them for us now, please? Well done if you're getting all of these right so far. Hopefully it's becoming a little bit more obvious, these patterns that we are creating. So, time to fill in some blanks and take it a little bit further. 10 to the power of 3 times 10 to the power of 3 could also be written as 10 to the power of something multiplied by 10 to the power of 5. It may be easier for you to write out these numbers as ordinary numbers, or you might be able to see the pattern already. If you're not too sure, don't worry, we're about to investigate further on the next slide together. So just give yourselves 30 seconds to write those down. If you can't fill in the blanks now, still write them down and we'll fill those in together in a moment. Okay, so for this one, we should get 10 to the power of 1 multiplied by 10 to the power of 5. And the second one, 10 to the power of 3 times 10 to the power of 7 is equal to 10 to the power of 10. See if you can notice a bit of a pattern between the 1 and 5, making the 3 and 3, a 3 and a 7, making a 10. Next slide, we're going to carry this on. Again, I'd like you to copy these down and see if you can find the rule for me. So we're saying a squared times a squared is a to the power of 4. These are all facts, those first 3. They are definitely correct. I want to see if you can find a pattern between those 3 and come up with a rule. Okay, so just give yourselves a minute or 2 and see if you can find that rule for me. Okay, let's have a look at the second one in a little bit more detail and we can just show what that rule is. A to the power of 3 multiplied by a to the power of 5. Okay, so let's rewrite it then as individual multiplications. So a to the power of 5, I've got 5 lots of a all multiplied by each other. A times a times a times a times a. and a cubed, I've rewritten that one as well. Okay, then we could collect all those together, and we know there are 8 of them there, and that is a to the power of 8. As we were told on the previous slide, that is true. So we can see from this then, this is our general rule when multiplying terms with the same base. So in the example above, a to the power of 5 times a to the power of 3, the base is a. You simply add the powers. So a to the power of m times a to the power of n, where m and n can be any numbers there. You simply add m and n together. So bottom right, as an example, 4 to the power of 7 times 4 to the power of 5. The base doesn't change, it still remains as 4. You add the powers there, 7 and 5. 7 plus 5 is 12. Okay, checking up on the first one, a to the power of 5 times a to the power of 3. Simply add 5 plus 3, makes you a to the power of 8. That will always work, and just going back to the previous slide, third one there, minus 2 plus 5 makes 3. It'll work for that as well, and the a to the power of minus 2, we'll discuss that in a slightly later lesson, what that means. Okay, so using some of that knowledge, I would like you to have a go at solving these equations, and you're going to fill in what each of these letters could be in terms of a power. Okay, so if you pause the video there, write those out for me and have a go at solving those. So welcome back then, and let's have a look. So for b, we should get to 10 to the power of 4, because if we're adding our powers, 10 to the power of 6 times by 10 to the power of 4, 6 plus 4 is 10, that makes 10 to the power of 10. Next one, just a little bit careful, 100 could be written as 10 squared, so 10 squared times 10 to the power of 7, 2 plus 7 equals the 9, that would work for that one. Third one, 10 to the power of 8, 10 to the power of 4, and then the last one, a little bit of a different one there. Any number divided by, 10 to the power of 6, divided by something is the same number again. The only thing you can divide by there is 1. But there's a special case with the powers here. You could call that 10 to the power of 0, which is equal to 1. And this is something I need you to write down for me as well and draw a nice big box around. Any base to the power of 0 will always be 1. So 10 to the power of 0 is 1, 7 to the power of 0 is 1. Any number you like, 2,754 to the power of 0 equals 1. Any number, power of 0 will be 1. We will investigate that further in a couple of lessons down the line. So, Amira has another one who's made a mistake here. The kids don't seem to be doing too well with their suggestions on this PowerPoint, and he's suggesting that 5 to the power of 3 is the same as 10 to the power of 3 divided by 2. Now, he is wrong. I want you to show some working to convince me that Amir is incorrect. Now, a couple of ways you could do this. One would be perhaps to suggest, again with the rules of BIDMAS, you would do the indices first. So you would do 10 cubed before you do the division. You'd work out what 10 cubed is. You get to your 1,000. 1,000 divided by 2 gets you to 500. Okay, you wouldn't do the division first, and that looks like that's what Amir has done. He's done 10 divided by 2 is 5, then he's cubed it afterwards. You'd know with BIDMAS, you'd have to do the indices first. Further proof at the bottom there. And just to show as well that we know that 5 cubed, one of those we need to start recognising cubic numbers. 5 cubed is 125. Okay, so a little bit of non-standard example, something shown a little bit differently. How many different calculations would give an answer of 10 to the power of 12? So, when we had a look at earlier where you were filling in what A would be or what B would be, you're going to tell me how many calculations can you create that would give an answer of 10 to the power of 12. Then, how many times bigger than 1,000 is 10 to the power of 6? Okay, so if you pause the video there and see. Now, I want to see sort of 3 or 4 minimum as different calculations for 10 to the power of 12 there. and then there's just one answer for the second part. Okay, so loads of different answers would be acceptable. The first one, I've just put down a couple of suggestions. Again, because we're multiplying, we're going to add the powers, so the 2 and the 10 make the 10 to the power of 12. And those two added together make 12. And then I've added in, you could have had as many different ones as you like there. That last one I like because it's got 3 different powers in there, 3, 6 and 3. Add them all together, again it makes 12. How many times bigger than 1,000 is 10 to the power of 6? So what we could do first is we could rewrite 10 to the power of 6 as an ordinary number. Okay, so that's a 1, and then we've got the 6 zeros after it. Because it's bigger than that, we need to divide by the 1,000 to see how many times more. 100,000 there. 1 million divided by 1,000 there, we've got as 1,000. So it's 1,000 times bigger. Or the second option, which again we will look at further detail in a couple of lessons down the line, is to look at it in both of them as standard form. So 10 to the power of 6 divided by 1,000, and 1,000 can be written as 10 to the power of 3. So 10 to the power of 6 divided by 10 to the power of 3 is 10 to the power of 3. Okay, and we've got another general rule. When dividing terms with the same base, you subtract the powers. A to the power of m divided by a to the power of n will become a to the power of m minus n. Here's another example. 10 to the power of 7 divided by 10 to the power of 5. You do 7 minus 5, which is 2. So it's 10 to the power of 2. Note how that's very similar to the multiplying terms. So when multiplying, you add the powers. When dividing, you subtract the powers. Okay. So again, make sure you've got that rule written down and got a little bit of a box around it for me. So what I'd like you to look at now is the rest of the worksheet that comes alongside this PowerPoint. It should be in the folder there for you. If you work through that, say we've covered a couple of questions already, see how much you can get through. Then when you've done that, we'll come back for a quick true or false. Okay, now you've had a go at the worksheet, just be aware the answers are in the folder as well. So please go back through and mark the work you've done, give yourself some big fat ticks there, and any mistakes you've made, just correct them, and then look over where maybe you've made a slight error. Okay, so for true or false, going to be a little bit different how we do this, obviously, without kind of closing our eyes and holding our hands up in the air. I would simply just like you to be nice and honest there, and when you've heard the question, pause it, ponder over it, and then decide if it's true or false for me. So to multiply by powers of 10, simply put a 0 on the end. Hopefully everyone listening to this has gone with false. That was Eva's suggestion at the start of the lesson. Also, we know that was incorrect. It's all about place value and moving that decimal point there. That is false. Next one, 10 to the power of 3 times 10 to the power of 3 is 10 to the power of 9. Is that true or is that false? Okay, that one is false as well. It should be 10 to the power of 6. When you multiply them, you add the power, so it would be 3 plus 3 to make 10 to the power of 6, rather than you don't multiply the powers. Check as well on a calculator. Throughout this, if you're unsure of something, double check on a calculator and that will prove to you this as well. Next one, to solve 10 squared times c equals 10 to the power of 7, I'm suggesting that c is 10 to the power of 5. Using what I've just mentioned on the previous question, hopefully we can get a full house on this one. Okay, so that one is true. We're adding the powers, so we would need to make 7. We need 2 plus 5, so it would be 10 to the power of 5. Next up, 1,000 times 100 is 100,000, which is equal to 10 to the power of 6. Is that true or is that false? Okay, ultimately on this one, it is false. 1,000 times 100 absolutely is 100,000, but 100,000 is not 10 to the power of 6. It should be 10 to the power of 5. Next one. 10 squared, and then all of that is cubed, is the same as 10 squared multiplied by 3. And what I said there, is that true or is that false? Okay, so on that one, that would be false. And again, it's sort of along the lines of BIDMAS. You would do the brackets first, B for brackets, so you would do 10 squared first, which is 100, then you would cube it after that, so 100 times 100 times 100, whereas obviously 10 squared times 3, you're doing the 10 squared, the indices first, 100 times 3 just gets you to 300, okay? So those are very, very different. You need to be aware that obviously cubing means timesing by itself 3 times, not multiplied by 3. Okay. And the last one, I believe this is 10 to the power of 3 times 10 to the power of 6 times 10 to the power of 3. Is that 10 to the power of 12? Yes, it is. That is true. Again, referring to that rule, we're adding the powers. 3 plus 6 plus 3, that is 12, so that is 10 to the power of 12. Okay, so well done for today's lesson. Just make sure you have finished off that worksheet and marked it, and then take a look in the folder for which Hegarty clips. They should be set for you online by your teacher as well. And then tomorrow, or the next lesson, whenever you've got that in a timetable, we will continue with more powers of 10, looking at large numbers. Okay. So look after yourselves out there, Year 8, and speak to you again soon.